Alright, finally here's questions 9 and 10. And in 9 we're asked to solve some logarithmic equations. In part A we have log base 4 of 1 over 64. And we want to see if we can write 64 with a base of 4. Well, we certainly can because 64 is 4 cubed. Then we want to see if we can get that 4 out of the denominator, and we can by writing that 3 as a negative exponent, negative 3. So 1 over 4 to the positive 3 is the same thing as 4 to the negative 3. And then we can either rewrite that as the exponential equivalent, which would mean 4 to the x is equal to 4 to the negative 3, or we can recognize that since this logarithm and this exponential expression have the same base, those operations would cancel each other out, leaving the exponent negative 3, showing us that negative 3 is equal to x. Now in part B we have two logarithms on one side of the equation, and we're going to use the product property to combine them into a single logarithm. If this was a difference, if this was a subtraction, then we would use the quotient property to turn them into a single logarithm, and this would be our numerator and this would be our denominator. But we have the product property, so we're going to multiply the x times the x plus 6 to write this as a single logarithm. And so this is log base 3 of x times the quantity x plus 6. And simplifying that product, we have x times x is x squared, x times 6 is 6x. So we have log base 3 of this expression is equal to 3. And then we rewrite this in exponential form. Remember that we cross the log out and we write this base to this exponent, and this expression comes to the right side of the equation. So 3 cubed, right here, 3 cubed, is equal to this expression x squared plus 6. Well, 3 cubed is 27, and this is a quadratic, and we can solve that easily by factoring. So we subtract the 27 from both sides, and then factor. X squared plus 6x minus 27 factors as x plus 9 times x minus 3. And then this tells us that negative 9 and 3 are possible solutions. Remember, if we put a negative 9 here, negative 9 plus 9 is 0. That makes this entire side of the equation 0. Same thing if we put a 3 here. 3 minus 3 is 0. 0 times anything is 0. So these are my possible solutions. They're my possible solutions, and I eliminate negative 9 because if I substituted that back into the original equation, I'd be taking the log of a negative number, and I can't do that. This solution, the logarithm is undefined for this solution, so that's extraneous. I've crossed it out, and so our only valid solution is x equals 3. Now, in question 10, we're asked to find a certain amount of time. We're given everything else in the formula, a equals p times e raised to the rt, and that amount A that we end up with, the yield, is $15,000, and the principal is $10,000, so I put that in here. The rate is 5%, which as a decimal is 0.05, and the time t is our unknown. Now, in order to get that variable out of the exponent, we're going to want to take the logarithm of both sides of this equation, and to do that I have to uncover that base. Uncover meaning that I have some number multiplied times that base. I can't have that to take the logarithm, so I, or at least in the way I want to do here, and so I divide both sides of this equation by 10,000. 15,000 divided by 10,000 is 3/2, which is the same as 1.5. And since it's an exact decimal, then I have no problem with the decimal as opposed to a fraction here. So 15,000 divided by 10,000 is 1.5. And now I take the natural logarithm of both sides of this equation, natural log of 1.5 here, and the natural log of e raised to some expression. Freeze that expression because natural log has a base of e, and so those operations cancel out as they've done here. And so I'm left with log of 1.5 is equal to 0.05 times t. And I divide both sides of the equation by 0.05 to get my time t, and that comes out approximately to 8.11 years. Okay, and so that's the end of this third video. And again, write, text, or call 464-5781, or you can write me at fbrantley@alamo.edu if you have any questions.